Hello, welcome back to another math video. Today we'll be talking about exponential equations. To be more specific, we will be solving exponential equations, find the value of the unknown to make each equation correct. So let's have the first example. So solve for the value of the unknown. We are given the equation 216 raised to 3k is equal to 36. Now again, very important when we are dealing or solving exponential equations, our first priority is to make each side of the equation of the same base. Now, how can we express 216 and 36 of the same base? So basically, 216 is just equal to 6 raised to 3. Alright, you can actually check that one using your calculator if you have your calculator with you. So we have 6 times 1 is just 6. 6 times 2 is 36. And then 6 times 3 is equal to 216. So again, we will try to express each side of the equation of the same base. So this is what will happen. Notice that again, our 216 is expressed as 6 raised to 3, and then raised to 3k is equal to 6 raised to 2, or 36. Now, using the concept or the rule of exponents, if we have a power raised to a power, we are going to simply multiply the two exponents. So what will happen is, we will have 6, 3 times 3k is just 9k is equal to 36. Now, if we are going to look at our equation, we actually have now the same base. So if this is now the case, what we can do is drop the base and focus on the exponents. Again, drop the base and focus on the exponents. So we will have our exponents are 9k and 2. So we have 9k is equal to 2. And then simply solve for k. So our k now is 2 over 9. That is for example 1. Example 2. We have 4 um, raised to x multiplied to 4 raised to 1 minus 2x is equal to 4x. So again, our goal here is to make each side of the equation of the same base. But if we're going to look at our equation, we already have 4, 4, and 4. And recalling again the rule of exponents, when we are multiplying two exponents with the same base, we are just going to copy the base and then add the exponent. So in this case, we are going to multiply 4x by 4 exponent x by 4 raised to 1 minus 2x. So again, copy the base, add the exponents. We have x plus 1 minus 2x, and then that is equal to 4x. What will happen now is we have x plus negative 2x is negative x, and then just simply copy 1 is equal to 4x. Now again, since we have now the same base, we are going to drop the base and focus on the exponents. So what will remain is just basically negative x plus 1 is equal to x. And then we are going to solve for x. So 1 is equal to x plus x, or that is just equal to 1 is equal to 2x. Solve for x, x is equal to 1 half. So again, our x value to this particular example is 1 half. Example 3. Alright, so example number 3. So we are given 1 over 64 raised to p times 16 raised to p minus 2 is equal to 64. If you notice here, we actually have a fraction. So first thing that I will do is convert this one into a whole number. Remember, when we are dealing with exponents and we have a fraction, we can actually make use of the concept or the rule that says if we have a negative 1 is just equal to what? 1 over a. So again, we are going to make use of this concept to express this 1 over 64 as a whole number. So 1 over 64 is just equal to 64 raised to 1. Then again, we are to copy everything. Raised to p times 16, raised to negative p minus 2, and 64. We are to simplify this one first. So negative 1 times p is just negative p. Then again, express everything of the same base. So 64 is just 4 cubed. 16 is just 4 squared. And again, 64 is just 4 cubed. So what will happen now is rule of exponents again. If an exponent or a power is raised by another power, we are going to copy the base and multiply the exponents. So what will happen now is we have 4. 3 times negative p is just negative 3p. And again, copy 4. 2 times negative p is negative 2p. 2 times negative 2 is just negative 4. Then again, copy 4 raised to 3. Now, to make, again, our solution simpler, we are going to simplify this side of our equation first. Alright? So let's try to do that. So we have, again, if we are multiplying exponents with the same base, we are to copy the base and add the exponents. We have 4. Negative 3p plus negative p minus 4 is equal to 4 cubed. And again, simplify. This is what will happen. We have negative 3p minus 2p minus 4. And then, negative 3p minus 2p is just 5. Negative 5p minus 4. And then that will give us again 4 cube. So since the base are now the same, we are going to drop the base and focus on the exponents. So we will have now negative 5p minus 4 is equal to 3. Negative p is equal to 3 plus 4. Negative p is equal to 7, or p is equal to 7, negative 7 over 5. So this will be our final answer. Example 4. We are given 36 raised to negative m minus 2 is equal to 216. Again, make each side of the equation of the same base. 36 is just 6 squared, and then 216 is just 6 cubed. So we will write 6 squared raised to negative m minus 2 is equal to x cubed. The same with what we did earlier, we are going to simplify this one first. So distribute the exponents. We have 6, and then 2 times negative m is just negative 2m. 2 times negative 2 is just negative 4. And again, that will give us, or that is equal to 6 cubed. And then since the base are now the same, drop the base, focus on the exponents. So we have negative 2m minus 4 is equal to 3. Solve for m. Negative 2m is equal to 3 plus 4. And then we will have 3 plus 4 is 7. So m is equal to 7 over 2. So that will be for our fourth example. For the fifth item or example, we have 4 raised to 3x is equal to 1/4. And again, since we have here a fraction, we are going to express this one as a whole number. So what will happen is we have 4 raised to 3x is equal to 4 raised to negative 1. And again, since the base are the same, drop the base, focus on the exponents. So we will have 3x is equal to negative 1, or x is equal to negative 1/3. Last example. This is my solution, but then again, I want us to solve it um, following the steps that I provided during the previous 5 examples. So again, you should get n is equal to 5 over